Okay, I think the YouTube live thing is going on. So, okay then. All right. Thank you very much for joining us for the last day. And then that one, third news, you two are only survivor of the workshop. So, kind of, what are those? So, then, so we only have two of you today. And so, yeah, we have as much time we want for the review. So, but anyway, yeah, so this is kind of, I mean, it's on live, but I mean, it's kind of casual meetup and conversation as well. So then let's see the final work. Then, okay, so, but anyway, as a premise, in case anybody watching now or later that what this workshop is about. So this is hierarchical modularity and growability in space architecture workshop. So each participant designed the module, like a module agent, which kind of grow in a way that like a module move along other module to uh, produce structure in space in a certain way. Yeah, so they worked on like a design and the mobility and then the aggregation slash formation of them. And then they are done, mostly done in processing using a very specific algorithm to generate a hierarchical formation. So, okay then. First, I'm gonna say, Giuseppe, can you go first to show your work?
Yeah, I prepared a video which summarizes everything that I've done. Let me know when if you can see the screen.
Right, not yet, but it's coming. I see the desktop. I think you are seeing the desktop, just desktop is black.
Yeah, my stop. Hang on, I stopped sharing my.
Sure.
I think. Sorry, I have some problem with my screen.
That's fine.
You
we are not in haste.
Can we maybe start with Shoko, and I'll try to restart my computer.
Okay. All right. So in that case,
sorry, yeah, because I need to. Everything now is frozen for some reason.
okay. So you're gonna be out of the meeting once and restart and come back?
Yeah.
Okay.
Okay.
Okay. Yeah. Then in that case, we're gonna go through. But all right. Sounds good.
Yeah. Okay. Sorry.
All right. Yeah. See you in a minute. So then, okay. In that case, Shoko, can you share your desktop screen and then start the presentation?
Yes. Okay. I considered the smallest surface that make up a gyroid to be a module and use an agent algorithm. There are two types of module, one for station and one for traffic. And this is one module. And this is a smaller module. The modules are connected to each other by repeat sliding and rotation. The large modules that make up a station form a cube, and when they are connected, they form large structures.
Right.
That's all. Thank you.
All right. Thank you very much. So I want to just give you feedback about the project in a kind of general architecture project feedback way. And then, so you started with the idea of gyroid, actually using that form as a kind of starting point of like thinking about the module, and then you develop a kind of connectivity between them, and you expand the idea for like a movement, and also that then you also develop like introduce a two defined type of module. So then one thing actually, just first technical question just to clarify if I understand correctly. So I see the yellow or orange-ish one is like a sequence of gyro surfaces, and then I also understand that the cube is like a more volumetric aggregation. But how did the agent of a big cube moved? But it looks like a overlapping cube. How did it happen? Like how did the other, or like the cube agent move between, or how it grew in time? So I think this one is linear, like a agent aggregation, right? The yellow line thing. Right. Can you explain the cube agent movement? What's the rule you gave to them, and then how they are moving, and then how they became that aggregated cube?
This is transportation line, so agent move on this line and between stations.
Right. Inside the station, you show the animation that agent moving almost like a random way, right? But is that actually a random movement, or is there a specific like an angle or direction? How do you design that movement?
Randomly.
Okay.
But random.
Okay. Then how did you put the cube, like a big cube geometry, on each like random agent? Because if you follow the random agent orientation, the cube also change the direction to random, but it seems you fix the cube orientation to stay same. Is that intentional, or like kind of some natural result of some rule? Like they are not like changing the direction. Like agent movement look like going the random angle, but your cube doesn't rotate.
Station to station is random, but agent to agent agent the agent are connected by 19 agrees.
Right? Can you show the like rendering of the first, maybe the first image or something? So this one, so you have a straight line that I think that's connecting between station. I think.
Not a straight line.
Right. But more linear thing and the volumes kind of aggregation. So you have to define the system, right?
Yes.
So, but the white one, the
yes.
cube, the location of agent look random, and then but the cube, like a geometry, cubic geometry look like overlapping each other, and they never change the direction of cube. They never go like a 30-degree. Well, so what was the reason of that? Or either like if there are any design intention or there's some rules or some reason how that happened? So it's like you want to have the cube in the same direction, or it's some byproduct of some process?
I want to cube same direction, but transportation line look like random walk agent.
Wait, the white line is the transportation. It's not the station.
White one is station.
Right. So I'm only talking about the white one, and then so you want to have the cube in the same direction. Is that intentional or not intentional?
Intentional.
Right.
Intentional.
Right. But in that case, I think your cubes are overlapping right now, right? They are kind of colliding each other. So, I mean that's one thing. But so one thing like a feedback I would give is like, I mean, if you want, okay, so there's several way you can, several things you can do, or any way you can do, but in reality, when you design some geometry, you don't want overlapping. So to avoid that, you have to like match the rule of agent to move in a specific way. So right now you use a random walk or random angle branching or movement, but you forcefully put the geometry to the same direction. So without rotating the geometry to the agent direction, you didn't do that. So as a result, they are same. But if you want to do that in a more precise way, you need to match the agent like a movement, like exactly. So it doesn't need to be like a cube stacking on top of each other perfectly. In that case, you want to just get the perfectly connected cube. I mean, if that's what you want, you could do that too. In that case, agent goes like 90-degree up or 90-degree left or 90-degree back or so, or orthogonal direction. But there's many other options to do. Like you can have like a its front bar like halfway shifted, or you could also have the agent to have movement to go diagonally. So in that case, if you want diagonally and then kind of keep all diagonal, you don't need to use a cube agent to have like a front of the agent being the front of the face. You can also have the diagonal corner is the front of agent. In that case, you have all like a three diagonal, three or six, actually, I don't know, diagonal movement agent, and then cubes are always kind of run beginning point is one corner and the end point is always the other corner of the cube. So they always match perfectly at the corner. So, but anyway, so it wouldn't be perfectly random, but still like a plus the shifting on the face, and you can still achieve the perfectly attached module and more kind of irregular. I mean, that in that case it's slightly irregular, but irregular or irregular aggregation, you can achieve that. So, but that's my feedback. And the other is about actually the bringing to different behind module system is working in terms of kind of composition. And but also you was I think first of your interest was that this gyroid geometry and how to use that, or what aggregation you can achieve. So once first you now see the whole aggregation, and then you can judge how the effect of this minimal surface, how it's kind of working or not working. So then, so right now this is really more like a pure geometrical expression. So there you might be able to find some use or some kind of characteristic of the surfaces, like a continuous surfaces, to use for something. So for example, you mentioned about the movement on this minimal surface, and I think you can achieve something can run on the surface somehow in a spiral or something. So it kind of almost stitching inside the surface of this aggregate, especially the transportation part, or in a yellow or orangish color. So I think you can still like explore that direction to have use of this module. But anyway, still like as a kind of for you to explore, for you to get into this kind of project, like agent-based aggregation kind of modular project, yeah, I think that's an interesting one. So, all right, thank you very much.
Yes. As for the white cube,
Yeah.
the current cube are overlapping each other, so I need to. They don't overlap, so the size of cube and the size of agent need to be. I need to be same, and
Yeah.
I need to think about the normal vector.
Yes.
I understand.
Right. So actually, but once you match the direction and orientation, maybe you could, it might be interesting to have not perfectly random aggregation, but like not orthogonal just cube aggregation, but something more geometry like a triangular or pentagon like aggregation, like some kind of Middle Eastern pattern looking, like a arabesque looking aggregation could be possible, or Penrose type of complex mathematical aggregation can be easily achieved with cube, I guess. So there's other possibilities. Then with this angle totally matching with the agent. So yeah, that'd be interesting.
Okay, I'm interested in Penrose tile, so
right.
I will give it a try.
Sure. Yeah, once you get into the think about 3D as well, I don't know what's gonna happen, but there might be something interesting. Anyway, all right. Thank you very much.
Thank you very much.
All right. Thanks. Okay, then all right. Next, Giuseppe, can you share the screen?
Yeah. Yeah, let's try now, see if it works.
Mhm.
Okay. I hope it doesn't crash again.
Right. I see the video screen or like a video.
Can you
play.
see it?
It seems it's coming. Yeah, I see the video player now. Yes.
Okay. Okay. Yeah.
Mhm.
Okay. I'll prepare a video and 1 minute. So.
Sure.
Yeah, that's all.
Good. All right. Can you like talk about the project, like explain?
Yeah.
Some project?
Yeah. So basically, the concept was to start with a very simple module, like a simple stick, which are connected to each other with flexible magnets in the idea. And basically, the overall 3D structure is basically created by a surface that is twisted in the 3D space. There is an incremental rotation that happen, and yeah, always based on the reference pattern, which is an hexagonal pattern. And the more that the pattern grows, it twists, and then it creates this sort of cellular particles structure. And then to that structure based on the agent location has been applied the module, and then the module was basically simulated for how it should in reality work, and so the overall structure is like this kind of lightweight structure, and yeah, I think this is in brief project.
Okay, that's quite interesting, and especially your module is kind of simple. I mean, like a simple to the degree you look like you could build that like within some time frame, and then so yeah. Then actually, plus so your agent or kind of module is super simple in terms of movement, a little bit like realistic movement. I mean, simple realistic movement, and then like the rule is also simple, like straight aggregation and then 60-degree turn, and then you have slight twist, and which make the whole structure in a very specific three-dimensional formation. So which is also interesting in a way, and then plus yeah, I wonder there is actually functional use of this form or not, which maybe you can keep thinking. Then, but yeah, so actually, are you thinking about like you are in the thesis or research group actually working on the modular robot, right?
Yeah, yeah.
So you might build some type of robotic module in a similar way, like this rotation-based thing, and I think you are thinking to like develop some mechanism of that.
Yeah. I was. I'm at the moment doing something that is like similar to this, but in a more like construction environment, so not space environment. So yeah, I presume that's obviously involves other consideration like structural feasibility or other kind of optimization and things like that. So yeah, the concept is basically having like a very simple custom robotic system, and then create a certain level of complexity, but from simplicity in a way. Yeah.
All right. So currently the complexity of the form is achieved by the introduction of the little twist, right? By twisting, it shifts the plane to grow and it creates three-dimensional form. And but still, like your base system is a hexagon shape, so there might be many more kind of way to go, like so out of hexagon system, and like aggregation hexagon system can be developed further. So I think this is just one of them. So then, but the module itself has can be any like angle, right? It can be triangle, it can be square, or even circle. That this agent or this module system, your kind of robotic module system, you are assuming can make any linear kind of rotated structure or kind of robotic formation. So I think that would be interesting for you to really like develop further with the possibility of your module. And then actually, I think the more interesting thing to think about is that when you develop the module further, can you show me the individual module explanation image, like how they this kind of. So so they are attached by certain joint, either mechanical joint or magnetic joint, or not sure about something, and then they rotate. Then, but you know when so first of all, one major issue is that when you have like sequence of module, they are attached on the top and the bottom, right? Then next is top. So when this one is moving along on the top level, actually this is already moving. So when you are when you have, so basically you have two layers of a module, like top layer and bottom layer, and if top layer module go on the top, this module wants to go to the bottom layer at the end because you are running on top of the top module. So, but anyway, so at the end you still have problem, right? You still have like a really kind of geometric and physical problem how they reach the end of module. So, but what I'm saying is that I don't know how to solve that, but there should be certain way. Then when you do that, module connection or module kind of mobility, like or constraint want to be changed. Like it might limit, it might limit, well, it might give you a very specific angle of like a tilting angle, not possibly that rotation joint might not be always like a perpendicular to the movement, and then that might give you the very specific constraints to your agent system, but that might also make the whole aggregation look interesting, possibly. So then another thing will be like so in your aggregation you introduce the twist angle system, and then but if you want to implement in this modular robot system, they need to have some twisted angle somewhere, right? So either you can introduce the like a second type module which already embeds the twisted angle somehow, or like already twisted module can be introduced. Although in that case, you need to think about how this guy move around the other agent. But anyway, so this kind of thing gonna also limit your agent behavior, but also give you very specific opportunity to to like aggregate in a very specific way, which would be different from the current aggregation, but that would make you or make your kind of aggregation design more unique and feasible, and then interesting. So yeah, I think that's it would be nice to really look into the mechanism and then change the agent to respond to that or to accommodate that.
I think the way that I wanted to move forward with this, and also with what I'm doing, is like try to make it like feasible, like something that can be built. So looking into this problem that you're saying now is definitely probably the next step, because with this as this design now is not obviously feasible, because you got the move on different levels, so it's not exactly 100% buildable. So
sure. Yeah, but yeah, I think that's that's a challenge to solve those mechanisms, but at the same time, like a design opportunity to extract a specific condition to apply to the behavior rule, and then that would make a really unique result. Actually, I want to just add one more like major potential problem / design opportunity is branching. When you want to put branch, so basically in that case, in your hexagon system, branching is one line going to two, but at that, so you need to have accommodate one joint which can have three directions of those modules, right? So in that case, you might end up having three layers of this linear joint. So that one. So that this animation has kind of skipped that part. They are kind of overlapping right now. Yeah, but you kind of need to figure out. But so this is a part when this current joint system or movement system doesn't really accommodate that condition yet. But if you figure out like you might change the like a joint system, or how either joint system, or how the module climb slightly up or down to be on the third level. If you figure that out, then again you wanna have a different constraint or limitation, but that also give you very specific shape to this. So that would be also interesting to think about.
Yeah.
Good. Well, actually, one quick one potential idea is like you can also introduce the different module which already has branch inside. Like most of them like one like a linear module and having two attachment points, and you could have like a more triangular or three-arm guy can walk along it with the same like a joint distance, and so it can still walk along it. But when it stays there, there's already 2 points to kind of stick to, and in that case, But that would be also interesting, like a multiple joint system which clearly like encode the branching behavior, etc. So that would be interesting too. Right.
Yeah.
Right. So it has a lot of potential. So quite interesting. So thank you very much.
Yeah, thank you for the workshop. Actually, it's been great. So thanks.
You're welcome, and I appreciate it. So okay, so that actually wrap up this 7 days workshop. Only 7 days workshop. In digital future. So, but again, thank you very much to stick to the last, and then just for the like some like things to for like office maintenance purpose. I need to just correct the animation, and also as I mentioned before or on the email, I need to correct the image for the exhibition organized by Digital Future. So please admit that. So I'm gonna edit everybody's image into one. Edit everybody's video into one video. So send me the video today, and then you can send me the board in a specific size I asked you by tomorrow. Then I'm gonna put into the pages of the submission. So yeah, please do that part. But again, as a kind of final wrap-up comment, yeah, again, so this was kind of this topic was kind of the topic I just thought of and then tried for the first time. So, but I'm still in the middle kind of development of the algorithm we used in the workshop. This hierarchical modular system, and we are still seeing, or I'm still in the middle of development of algorithm and also the application of that. So last year was a more kind of application with assumption of some kind of cultural heritage or inspiration, and with very simple geometry. But this year was more complex geometry then for the application of this space architecture scenario. And maybe next time I might try something else. I don't know, or I might continue doing the space architecture stuff. But anyway, but thanks to you, I saw the kind of range of work. Or even, I mean, some participants didn't really survive till the end, but during the course, and when they are working on their stuff or the assignment, they also showed some range of work or possibility with this approach or this algorithm. So I really appreciate everybody who here, and also who was a part of the workshop, and also some people actually taking the workshop via YouTube, etc. So I really appreciate this opportunity, and I really thank you all for that. All right, thank you very much. And then now I just wrap up. And then maybe I hope I continue my research and design activities. So I hope I see you guys sometime later. All right.
Thank you very much.
Right.
Thank you for everything. Thanks.
All right. Thank you very much.
Thank you very much.
All right.
Thank you.
Thank you. Bye.